This is Quideo number 2, advanced question. The advanced question gives us a chart of years from 1977 to 1990. It gives us the number of powerboat registrations in thousands for those years and the number of manatees killed. The question above says that the manatees have lived on the Florida coast for many years, and they have been slowly dying by powerboats. First, it tells us to create a scattered plot of the relationship between powerboat registrations and manatees killed. So here is my scattered plot. On the x-axis, we have powerboat registrations in thousands from 400 to 750, going up by 50s. And on the y-axis, we have manatees killed going from 0 to 50, going up by 5s. A says, describe the direction of the relationship. Are the variables positively or negatively associated? The scattered plot showing the relationship between the increase of powerboat registrations throughout the years and the increase in number of manatees killed has a moderately strong positive linear relationship. This means that as boat registrations increase, so do the amount of manatees killed. As you can see, you see the positive slope of this scatter plot. B says, describe the form of the relationship. Is it linear? The relationship is linear. You can see the plotted points increase as more powerboats are registered, creating a straight line. C says, describe the strength of the relationship. Can the number of manatees killed be predicted accurately from powerboat registrations? If powerboat registrations remained constant at 719,000, about how many manatees would be killed by boats each year? The relationship is relatively strong. You can predict the number of manatees killed by the amount of powerboats registered. If the number of registrations remains constant at 719,000 for the years following 1990, then we can predict that there will be an average of 45 to 50 manatees killed each year based off the data from 700 to 750 powerboat registrations. This is Quideo number 2, AP question. The AP question talks about windmills that generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity produced in amperes for one particular windmill. They randomly selected 25 days and computer outputted the regression analysis for the production of electricity based on wind velocity. Here is the regression analysis that they gave us. Part A says use the computer output above to determine the equation of the least squares regression line. Identify all variables in the equation. So you'll use the equation y equals a plus bx, y being the predicted electricity production, and you use a is 0.137 and b is 0.240. So for our equation, it would be y equals 0.137 plus 0.240 times the wind velocity, which would be x. B says, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles per hour? So you would use the same equation from above, the y equals 0.137 plus 0.240 times wind velocity. You would plug 15 and 25 in for wind velocity, find the totals for each, and subtract the lowest from the highest. And you should get 2.40. The slope of this data is 0.240, which tells us that each miles per hour wind speed added the electricity production increases by 0.240 amperes. It increases because the slope is positive. The difference between 25 and 15 is 10, so you multiply 0.240 by 10 and you get 2.40 amperes, which is 2.4 amperes higher when the wind velocity is 25 miles per hour than on a day when it was 15 miles per hour. Part C says, what proportion of the variation in electricity production is explained by its linear relationship with wind velocity? There is an 87.3% variation in electricity production. This is explained by the r-squared value given to us by the regression output. Here you can see the r-squared value of 0.873. You just hop over 2 spaces, put the dot there, and you get 87.3%.